Find the power series representation for the following function. Also find the interval of convergence. The function given here is x squared times tangent inverse of x. Okay, so first we want to find the power series for tangent inverse x, then later we multiply by x squared and we are done. And we know that the power series for 1 over 1 minus x is given by sum xn. X is in fact whatever we have here, that goes to n, and absolute value of that less than 1. Okay, so if we have 1 over 1 minus something, then we have power series, but we have tangent inverse, and we know that the antiderivative of 1 over 1 plus x squared is tangent inverse x. Okay, so the power series for tangent inverse can be found by the first writing the power series for 1 over 1 plus x squared and then integrate. So we need to find the power series for 1 over 1 plus x squared and integrate, then we get the power series for tangent inverse. So we start finding the power series for 1 over 1 plus x squared. Okay, so in this way, note that 1 over 1 plus x squared, because we can write this in the form of 1 over 1 minus x in this way. This is same as 1 over 1 minus negative x squared, and this can be written in the power series in this way, and from 0 through infinity, so whatever we have that raised to n, so negative x squared raised to n, and this is valid for absolute value of x less than 1. That's absolute value of negative x squared less than 1. Let's simplify this, and from 0 through infinity, that's negative 1 x squared, so negative 1 to the n, x squared raised to n, which is same as x raised to 2n, and absolute value of negative x squared is same as absolute value of x squared, and x squared is always positive, so we don't need absolute value. So this is basically x squared less than 1, and if we take square root both sides, we get absolute x less than 1. Okay, when we have x squared less than 1, we take square root both sides, then square root of x squared is absolutely x less than 1. That means x is in between negative 1 and 1. Okay, so at least we found the power series for 1 over 1 plus x squared, and we know if we integrate both sides, then antiderivative of 1 over 1 plus x squared is tangent inverse. Okay, and we get the power series for tangent inverse, and later multiply by x squared to get the final answer. Now this is, let me write over here, 1 over 1 plus x squared is this power series. Integrate both sides with respect to x, so let me put this integration sign, integration with respect to x, integration with respect to x, then we get tangent inverse x plus c, or we can write plus c on the right side, doesn't matter, or plus c, let me write here, c plus tangent inverse x equals, and when we integrate a power series, we can do term by term, basically integrate this x factor. So this is n from 0 through infinity, negative 1 raised to n. So when we integrate x raised to 2n, this becomes x raised to 2n plus 1 divided by something 2n plus 1, and this is valid when absolute x is less than 1. Okay, so let's simplify this. Basically this is simplified already, x raised to 2n plus 1 over 2n plus 1. Now we need to figure out the value of c, because this is arbitrary constant. For that we can take, because this is true for all value of x when absolute x is less than 1, so this is in fact same as x is in between negative 1 and 1. So let's take x equals 0 just to figure out c. Take x equals 0, we get c plus tangent inverse of 0, which is 0, equals, when x equals 0, we have 0 raised to anything is 0, so right hand side is 0. This implies c must be 0. So basically this constant is 0. Thus we have tangent inverse x, the power series for tangent inverse x is sum -1 to the n x raised to 2n plus 1 divided by 2n plus 1 n from 0 through infinity, and this is valid for absolute x less than 1. Okay, so this is for tangent inverse, but the question is x squared times tangent inverse. So for the function is x squared times tangent inverse x is x squared times the power series for tangent inverse x is found here, -1 to the n x 2n plus 1 over 2n plus 1 absolute x less than 1 and from 0 through infinity. Now we need to take this x inside the sigma sign, and we can combine this x square and this x. We have the same base x. All we have to do is add the exponents, and 2n plus 1 plus 2, we get 2n plus 3. So the power series for the given function is, so this will be the final step, -1 to the n x raised to 2n plus 3, 1 plus 2 3 divided by 2n plus 1, and the interval of convergence is in fact -1 to 1. Okay, x is in between -1 and 1. Final.